Q1 2020 update. Myself and Paul Status will run this event. Please direct all your queries, comments, and questions to the webinar mediator box. Just over to the side, you should be able to access that. And any questions you have, we're going to nominate some time towards the end of the webinar to just go through them with you. If you have any questions for the host, BICSI CEO, or either of the presenters as they come through. Hi, Bill. Welcome. BICSI credential holders in attendance will be allocated CECs, provided they have registered to attend this webinar. So it's very important that you register up front to all webinars just so you can take advantage of those seminars, of those CECs. Let's move on. Okay, so first up, I'll just give a quick intro as to what's happening. Then we'll move on to Paul Status, which is the BICSI South Pacific CEO at 11:05. At 11:15, we'll have our first presentation brought to you by Wayne Allen, who's a product marketing engineer for Fluke Networks. Then at 12 p.m., these are all Eastern Standard Time, 12 p.m., we'll have our second presentation, fiber optics, the need for fiber everywhere is driving densification. That will be brought to you by Jason Hanlon, the commercial manager for Datacom, Prysmian Group. And then at 12:45 p.m. Eastern Standard Time, we'll have time for Q&A session and any questions and queries that come in. So first off, is why web seminars, why we're going down the road of web seminars and not physical seminars. As you all know, COVID-19 has forced the suspension of up to about 9 Q1 BICSI South Pacific seminars and postponed of May the New Zealand conference coming up, unfortunately. So it's had a big impact. Globally, BICSI has postponed several other Q2 and Q3 conferences. However, we do have a responsibility to bring to our members and to facilitate education, networking, and credentialing, all of which can be done online. So BICSI are now stepping up to the forefront to bring everything to you online. Thanks to Fluke Networks and O&M for facilitating our South Pacific webinar. So they're our sponsors for this webinar today. Moving on, BICSI plans moving forward. So what we're going to do, we're going to host fortnightly webinars on an ongoing basis. So we're now, instead of having monthly seminars, we're moving it on to fortnightly webinars. And we're going to record all webinars, so just notification to everyone that this webinar is recorded, and it will be made available for members only to download. So again, point to register and become a member where possible. We will notify members of other members where there is other sources online where you can get education in the ICT industry and also be provided with CECs. So watch this space. We will be strongly monitoring government and health authorities and their directives on restrictions, which are looking to defer the BICSI New Zealand conference Q3 later this year. So BICSI web seminars. So we've already had one. So this is our second one this year. But we've now opened it up out to outside the Pacific. So we'd like to welcome our Japanese callers who have dialed in today to this webinar. So you're very welcome, and thanks for making the effort to attend. We are on that similar time zone, so it's good to have them on board. So we've had a webinar already, which was Tuesday the 24th of March. It was hosted by our Queensland coordinator, Mr. Craig Buckingham, who is also an RCDD, and he hosted that on O&M's go-to webinar platform. So what was presented there was new options for wireless LAN technology, and that was presented to you by Craig Clay from CommScope Ruckus. And the second presentation for that was the importance of the foundation layer and its role in the future of our cities. And that was brought to you by Adam Davis. So they were the two presenters for Craig Buckingham's webinar. And I believe that was recorded, so it will be available to members. Obviously today, Tuesday the 7th of April, is hosted by myself, and I've already gone through our presenters for today. So I won't read that out again. And then we'll have another one coming up later this month, Tuesday the 21st of April, hosted on R&M's go-to webinar platform. And that will be major changes to the ISO 11801-1 and the IEEE 802-3 CT and their impact on the Australian and New Zealand. And that will be brought to you by Murray Teal from VTI Services. Okay, without further ado, I'm going to hand you over to the CEO of BICSI South Pacific, Mr. Paul Status, to just run you through the next couple of slides. Thank you.
Many thanks for that, Daniel. If you would mind just stepping us through the slideshow, just move on to the next slide if you could.
Okay, there you go.
That's just showing the welcome to the BICSI South Pacific seminar.
Oh, hang on. Yeah. There you go.
Well, I can only see that. So not sure what everyone else can see. Just bear with me a minute. Are you looking at my screen or am I looking at your screen?
You'll be looking at the screen presenting across. So BICSI training, is that the one you want to start with?
Yes, if you wouldn't mind.
Yeah, so that's up now, so you're good to talk about that. Can you see it?
No, unfortunately I can't.
Okay. Oh, maybe I'll stop presenting 1 sec. Yeah, I think I have Paul, sorry.
Well, if you can present and I'll just talk over the top. So if you take back presenter. There we go, perfect. All right, fine, I'll just talk through that. I can now see what I'm talking about. All good?
Yeah.
Excellent. Well, ladies and gentlemen, thank you also for participating and attending. We know it's rather challenging at the moment, just in terms of dealing with this rather crazy world that we're living in. The interesting thing is it's affecting us globally. So what's important now is that organisations like BICSI and other associations look for ways to provide value and engagement with our members and with industry at large. So just on that point, I've spent a lot of time speaking with various organisations, doing some research. A lot of members have been providing me with some information. So importantly, to recognise the fact that many of us are locked in our homes. We're still trying to work, but we're working online. It is creating an opportunity to engage in a little more education opportunities. So I'm rather pleased that BICSI headquarters recently announced that they've got a number of their online courses are free or discounted. And you'll see on that hyperlink that there is information there. There's a wealth of information, wealth of activities. I expect that this will grow. Again, I can't promise anything, but currently have that list of free and discounted courses. We sent the message out to BICSI South Pacific members last week. A number of folk have come back and looked at it and indicated that they're interested. Some have indicated that they want more. So we'll feed that information back to BICSI headquarters. So if you've got any criteria, anything you're looking for specifically, by all means, please give us the feedback that we need and we can convey that to our head office. BICSI HQ has also indicated that they're exploring options to offer some of the traditionally instructor-led courses on the virtual platform. And this takes a lot of work to get organised simply for the fact that it's difficult to construct. You need some solid web platforms to be able to do it, to provide that interactive situation, and also the migration of instructor-led material across to a web-based platform. So watch this space, and as we have more information coming to us, we'll convey that to you as well. The other point is that several BICSI corporate members, both in the South Pacific and elsewhere in the world, such as I've just cited a few that I've seen, CommScope, Simon, Annixter, they're offering many of their courses free online. So once again, a great opportunity to be able to access some of the education facilities, importantly from an education point of view, but secondly for our credential holders, an opportunity to obtain very important CECs while you've got the opportunity to increase your knowledge. I noted also that BICSI, which is the Professional AV Association, have done the same thing, and they've indicated that till the 12th of June, all of their courses will be available, all their online courses will be available free. So once again, let's take advantage of the information that's available to us. And the final point there is that we've been in discussion with Engineers Education Australia. So that's the educational component of the Institute of Engineers here in Australia. In fact, I made a submission on Friday to them about proposing an online ICT infrastructure course. This is not specifically for ICT folk. This is to go out to the wide range of engineers. And as we know, the Internet of Things, smart buildings, autonomous vehicles, etc., is forcing ICT infrastructure onto other disciplines of engineering, whether it's electrical, civil, structural, mechanical, etc. So our discussion with Engineers Australia is that we can provide these engineers of other disciplines an introduction to the whole concept of ICT infrastructure, so that when they deal with these issues in the future, they will be able to obtain an education. That, of course, the idea of that is it creates a pathway or stepping stones leading up to more skilled, more knowledge in the ICT infrastructure space, and ideally pushing people towards some of the BICSI credentials such as RCDD. So that's an important program that we've been working on. So I thought I'd just share that with you. Go to the next slide, please, Daniel. Daniel, I'm assuming you've got control, so if you could, thank you very much. Now, this is just a snapshot of what's happening within this year with regard to South Pacific conferences. We've had extensive discussions as a board on this and tried to make some decisions looking at the various scenarios and the consequences. Unfortunately, COVID-19 is a difficult beast to try and qualify. So as Daniel mentioned, we've postponed our New Zealand conference, which was scheduled for next month. We have currently set a tentative date of the 29th of September. I'll explain the reasons behind that. There is concerns that with so many events being deferred in the first half of this year, it will become a very crowded place in the second half of the year. COVID-19 might last longer, we don't know. But we took advice from our venue, Ellerslie in Auckland, to make a tentative booking. We are exploring further options from there, and we're going to monitor that regularly. So we'll let you know as to how that progresses. Just recently, the board met to discuss the concept or what will happen with the Australian conference, and simply because of the crowded platform of different events, etc., we've elected to postpone the Australian conference into 2021, and the plans there are late 2021, and we're aiming for Sydney. We're looking at venues as we speak. So that brings us back to 2020. What is happening there? We're contemplating creating a two-day event in New Zealand, including the Excellence Awards, including the new concept we're experimenting with, Technology Experience Zone. So it may become a major conference. Again, it all depends on what guidelines, what government restrictions there are. We might find that New Zealand will keep itself isolated all the way into the end of 2020. So it might be just a New Zealand-only conference. We're still exploring, so please bear with us in regard to the uncertainty of what we're doing with it. But as soon as we've made some decisions and have some better vision as to what's happening, we'll let you know. And as the second point says, we're monitoring government and health authority directives all the time. That's a regular feature of what we're doing here in the BICSI office. In conversation with BICSI headquarters about this situation, they're exploring the concept of an online super conference and then utilising some of the speakers from the many conferences that are being cancelled for this year. So again, that's still work in progress. We'll keep you up to date with what's happening. Not sure if any of you did attend the Cisco Live event for Australia last week. They, as you know, they deferred their physical conference, and they held a two-day WebEx seminar or event. I attended some of it, listened in, ran very, very well. In fact, what you're seeing now is very similar to what they've done. The slides, with the video of the speaker at the side and the audio coming through and being able to record it all. So we are working with, I guess, what many consider best practice, and we're looking at utilising that. So again, keep an eye on what's happening with information on that. And the latest I heard, the BICSI Fall Conference, which is scheduled for late September, the plans are still in place for that to happen. But again, we'll let you know what happens with that. Next slide, thanks, Daniel. Okay, just a quick snapshot of the big ticket items for 2020. As BICSI sees it, self-isolation's intensified. I've just popped up a web link there for what NBN have put up in terms of they're recognising enormous influx of demand for bandwidth as a giant proportion of workers in Australia, and by extension that all around the world, are now working from home. So that really intensifies the value that we as ICT infrastructure professionals can do. End users are finding, in fact, I'm hearing from various folk that staff working from home simply don't have the infrastructure in place. So there's an immediate demand for various actions to improve performance. Sometimes the wireless network isn't good enough within a home. Sometimes the broadband infrastructure isn't up to speed. Interesting, I had a conversation with one of our members in New Zealand yesterday, and Chorus approached them asking for some assistance and guidance in terms of how to make it function very well. What they're finding with a very good broadband network in New Zealand, their fibre to the home, it's now that last 10 metres that's creating the problems. So this emphasises the value that we provide. We are an essential service, and I cannot emphasise that enough. As billions of people work from home now, the demand for reliable infrastructure and reliable communications cannot be more strongly emphasised. So once again, my little comment at the end there, let people know that you are an expert in ICT infrastructure and you are available to help them function business as usual. So by all means, let people know of your skills and your knowledge. The next slide, please, Daniel. Okay, so just a quick snapshot, quick summary of what we're doing. This is our last slide. What to do if you're self-isolated, which seems to be a vast majority of people these days. Office workers are moving into that space. A good place to go is to BICSI.org. If you're a member, go and have a look at the 2020 Winter Conference. All the presentations are there. I attended that conference in February this year, and it was superb. There are some excellent courses mentioned in there, presentations, well worth having a look at. That's free access to BICSI members, so log in first. If you're not a BICSI member, if I can just put in a plug, it would be worth your while to join up, and then you'll get free access to not only that conference, but going back several years for the conference programs. Very well worth getting access to. And as I also mentioned, the second bullet point, we have a number of online courses. There's a couple of examples. Intelligent buildings and the network economy, fundamentals of bonding and grounding. There's some very good BICSI training programs. Some of them are free, some of them are discounted, some of them are not. Have a look at that. We've sent the link out to BICSI members last week. If you need more information, by all means, give me a call. And I'm in the office, so you're welcome to talk to me. CommScope have got a very good presentation, one of their free training programs, wireless RF and microwave. The VICSA project management for AV. These are just a couple of points that I found. We will be putting out a more comprehensive list of free training programs, free courses that our members are offering, some with CECs. And I commend those of you who have sent me information about that. Thank you very much for that information. Download these recorded BICSI web seminars. We'll be doing them fortnightly. And a point I really wanted to stress at the very end here is share something positive about coronavirus. I know we're all sick of hearing the bad news about it and what it's doing to us. What about this? What about that? There was a lot of constructive material that's out in the marketplace about things to do, viewpoints of what the economy will look like, even of some humorous things that we're seeing. We are all sick of hearing the negative things about it. So please share some positive things. Use social media to your advantage. Put the word out and be seen as an expert, visionary person in this particular space. So with that, I'll conclude and I'll hand back to Daniel.
Thanks, Paul. Okay, without further ado, we're actually running on time, so I'm going to introduce our first presenter this morning. So what we've got is the changing state of standards, and that's brought to you by Wayne Allen, Product Marketing Engineer for Fluke Networks. Okay, Wayne, if you're happy to take over.
Okay, if you'd hand control to me, thank you. Just hopefully my screen is sharing there.
Yeah, we can see that, Wayne.
Okay, that should be full screen now.
Full screen it is, yeah.
Okay, thanks very much, Daniel. Well, good afternoon or good morning, everyone, whether you're in New Zealand or Australia. I thought it'd be interesting in these times where we're relying on network connectivity and things like that to look at where standards are taking us. And I got to admit, in the last 18 months, some of the standards have changed pretty dramatically. What I'm going to show you and talk about is not everything, but it's a fair chunk of what's been happening in the world. So what we have is really the need for speed, and bandwidth and speed is what's driving things that are happening at this present point in time. Higher speeds and the ever-growing need for bandwidth. Just recently, the standards bodies completed their 400 gigabits per second work. So they've got all that addressed, and a lot of that is now being published. And just recently, they've just started to work on 800 gigabits per second and 1.6 terabytes per second. As you can see from the Ethernet Alliance graphic there, since 1980, pretty slow in their development. And just recently, we've had a raft of new standards that we can work with. This graphic covers both fiber optic and copper, of course. So the Ethernet Alliance has got mapped out what speeds and roughly when. But I think the key takeaway here is that we're going to see a lot more single mode, especially in data centers, and a lot more parallel optics. I don't know if you saw this the other day, but Nokia Bell, they managed to achieve 1.52 terabits over 80 kilometers of standard single. So that 1.6 terabytes is looking pretty good over 3 to 5 years. Looks like the Ethernet Alliance is right on track to deliver what we need. That's pretty phenomenal data rates. I don't know what that equates to, how many Encyclopedia Britannicas per second, but I think it would be a significantly large amount. So just a look at where we're heading here, and this is multi-mode. You have 802.3cm, which is the next generation of multi-mode PHY. It's been published, so this is 400 gigabits per second on multi-mode fiber. You have 400G base SR8, so that's a more traditional form of 400 gig, where we use 8 pairs of multi-mode fiber. So that means 16 fibers, 8 lanes as the 8 designates there, so that's 16 fibers. And that pushes us into a new connector called the Focus 18. So I've got the 12 fiber connector there on the right, and you can see the 16 fiber connector on the bottom there. Those lanes, of course, break out, so you can support 50, 100, and 200 gig. But you need to sort of look at the distances there as well. OM3, 70 meters, OM4, 100 meters, and OM5, 100 meters. So you've got to watch the distances there. So if you're looking at upgrading older systems, or you're installing multi-mode fiber now and you want to have a migration path down the track, just watch those distances that you're using. And especially down the bottom, look at the channel loss there, 1.8 dB. That's across the whole channel. That's the link, the patch cords, cross connects, you name it, 1.8 dB. That's a small number. So you're going to have to look at your testing. And within that regard, 14763-3 is being revised. The Australian Standards Committee working on fibre optics is one of the lead organisations helping to revise that. And MPO field testing support's been included in the next issue that will come out probably next year. There's another interesting format for 400 gig, and that's the SR4.2. And as the 4 says, that's 4 lanes or 8 fibres. But the .2 means 2 wavelengths. So they're actually going to use 4 pairs of fibre and the 840 and the 9 wavelength to transmit. So because those wavelengths are pretty close to the 850 and of course we've got the 1300 with testing, so your standard testing will support this. Distances and channel budgets are again tight, but if you have a look down the bottom there at OM5, 150 metres, 2 dB channel budget. So this is one of these newer applications that supports the wideband multimode fibre. They haven't been slow on single mode Ethernet either. So if you look at single mode fibre, what they're looking at is getting beyond the 10-kilometre limits. And one of the interesting ones is 802.3cn. And there's a number of flavours there. You've got 50 gig, 200 gig and 400 gig. And the first iteration there is 40 kilometres. So we're now moving into the area of telco and disaster recovery-like information. You'll see that you've got 40 kilometres available there. And you might think the maximum channel loss at 18 dB is quite a big number, but in reality it isn't. And you're looking at an engineered channel here because 40 kilometres of OS2 at 0.4 of a dB per kilometre, you're already at 16 dB with just the fibre component. And you haven't started to consider any splices or any connections. So it's what they call an engineered solution. Testing at 1310 and 1550 will be important, especially at these longer distances, because if you've got a problem with single mode fibre, it's going to show more at the 1550 nanometer wavelength. So that will become important. And then on top of that, you've got 2 other standards, the CT and the CW standard, and they're looking to go to 80 kilometres. So these are very high-powered outputs from the active equipment to reach out there to 80 kilometres. And I have another little picture across the side there that I got from the Ethernet Alliance, but I thought it was interesting in how you can take parallel fibres, speeds, and modulation types to achieve right out to 800 gigabits per second quite easily. Just excuse me. No, it's not COVID. I'm not dying. Dry throat. So we've seen rapid change in bandwidth. And I saw this graphic and I thought, yes, I'd like to borrow that. And what you have here is where we've been for the last 35 years. It's been a pretty slow build-up. 6 rates in 35 years. But in the past 18 months, we've had 6 new rates. So that's a huge acceleration. Longer distances, we're trying to make single mode fibre go through multiple generations of network equipment. It's becoming more price competitive, and it's becoming the preferred solution in hyperscale data centers. And I think the other key thing here is parallel optics is going to be fairly big in this area. So choices on multi-mode are fairly wide here. You've got quite a lot of different types of applications available. Key, I think, is these channel numbers. We tend to test links, and that's where we can come unstuck. We can get link numbers down here quite easily, but it's when you put everything together to create the channel, that's when we're going to run into some issues. So people designing systems and people speccing systems need to have a look at how the operator is going to use the links that are being installed to make certain that the channel budgets can be achieved. And here's your single mode version. So from 40 gigabit, 400 gigabits on single mode fiber. You've got multiple lanes, multiple fibers, but a couple of things that people need to watch here. The IEEE is now speccing reflectance, and that's a direct measure of how clean your connectors are in single mode fiber. So to measure reflectance, that takes an OTDR trace. So if you're looking at single mode fiber in a data center or connecting between buildings, or as a part of a disaster recovery solution, not only do you need to look at the loss with a light source power meter, I'll deal with that in a moment, but you also need to look at the reflectance coming back from the link, how clean the connectors are and how good a quality the connectors are. And talking of channel loss, here's the channel loss. Again, the 6.3 dBs there at 100 gigabits looks a pretty big number. But if you consider that's 10 kilometers, you've already got 4 dB from the fiber. 2 connectors at 0.75 of a dB, you're up to 5.5 dB. 2 splices, 0.6 of a dB, you're at 6.1 dB already. So if you can consider there the fiber, the likely cross-connecting, patching that's going to go on, you're going to have to be very careful with the install and how you go about testing the installation. So how do you support this? How do you make certain that it's all going to work? Well, 14763-3, we either love it or hate it, depending on where you are out there. It's getting a major rewrite. And really the guide the international standards people gave the standards committees is make it the Bible for fiber optic testing. One document that you can go to and find out what you need to do to test fiber optics. So it's got everything in it that you're used to seeing in the document. And the Australian standard ASNZ 14763-3 is based on this document. What's been added is MPO testing using light source and power meters or optical loss test sets that use NPO connectors. That wasn't covered in there, and it is now. And the underlying document is 61284-5. So that deals with the different configurations you can have. There are some new link models. With fiber, we try to mirror what we do with copper links. So we're going to see an MPTL link. So that means a field terminated connector at the end of the fiber, because there are CCTV cameras that can be plugged directly in. And we will most likely see some wireless access points that plug directly into fiber optics. The next generation of Wi-Fi is version 6E, and that's pretty high speed. That's 10 gigabits per second. But there's another one following in behind there that they're calling Wi-Fi 7. It's 30 gigabits per second. So you either feed that with multiple copper runs, Cat6A copper runs, or you feed that with a fiber. So that's the thinking that's going on behind MPTL or fiber. And that's modular plug terminated link. And also to match the work on end-to-end links, which is where we have an RJ45 style connector at either end of a link. no patch panels, no switches in between. We've got to be able to do the same for fibre optics as well. We're also removing the enhanced 3-chord test method. In reality, not many people use this method. It was there to support older test equipment, but the majority of test equipment manufacturers today have changeable adapters on their input ports for measuring power. So it made no sense to leave the enhanced 3-chord method in the standard. Single mode testing is going to be revised. We're going to move it from the current 5K limit, and we're going to move it out to 10K. And I don't think a lot of people in industry realise that 14763-3 is really a premises style or structured cabling style standard. And it was only ever designed to support single mode to 5 kilometres. And yet every day I get phone calls of people wanting to test longer than 5. Well, we're going to take it out to 10 kilometres under the auspices of the standards committee. But if you need to test single mode fibre beyond that 10 kilometre limit, talk to your vendor or talk to your consultant that's dealing with the project and take their guidance. And of course, you can always give me and I'll give you some guidance. In-phase inspection will still be a requirement. Sorry guys, this is not going to go away. If you looked at the single mode stuff earlier on, you noticed I had reflectance numbers, and reflectance numbers are directly related to how clean a connector is. So looking for dirt is not going to go away. They are moving to edition 3, so it's more simplified, 2 zones rather than the current 3. But passing and failing, there can be variabilities because of shadowing, the way we illuminate fibres. So what they've done is they've said you should be inspecting, but there's an option there not to do a pass-fail. You can do what's called document only, and that's to supply an image of the end face as part of the documentation. And then someone will look at that and decide whether they're happy or not happy. You'll still get the radials on the image there, as you can see in my image. You can make the assessment with the Mark I eyeball whether that's a clean. And to make it a little bit easier, they're finding that scratches are not the huge problem they thought they were. They're a problem if they get large, but small scratches are not a problem. And so they've relaxed that requirement. But the really big killer is dirt. And that dirt often, when it comes to testing, comes from your finger accidentally touching the connector. So it's becoming a major. You will have to deal with some new connectors. As we go faster, we want more bandwidth. The interface electronics has to change. I borrowed these graphics from the Ethernet Alliance. I thought they were quite interesting. Everyone will be familiar with the RJ45 and the SFP and probably the QSFP. But now you're seeing SFP double density. In other words, twice the amount of connectors in the same footprint. And as you go higher, right up to beyond 400 and beyond, you've got QSFP and QSFP double density. So double the amount of connectors on the same footprint. That's not really possible with an LC connector. So what you're seeing is the emergence of a new connector. It's called the CS connector. It was put forward by Senko and it's manufactured by Senko. And I thank them for the use of the images. But it's the interface of choice for double density. And as you can see by the picture there, it's quite a small connector and you can fit quite a lot of those in the same space as the good old LC connector. By the way, the ferrule size is still 1.25. You've also, the IEC has also recognized 2 other connectors, and that's the SN connector and the MDC connector. The SN connector is from Senko, and the MDC connector is from our friends at US Connect. So they're also out there, and I think the market will dictate to which connector becomes going. And we can't forget that some of these new applications require 16 or 32 fibers, and the Focus 18 MPO and MTP type connector will support 16 to 32 fibers. Good thing with these new connectors, you can test them using the current test equipment. You won't have to change your equipment. You can use hybrid cords. You can use one jumper or three jumper reference method, and you'll be able to test these with no problem. And I've got an image there of using the three jumper method on certifying a link using CS Connect. Likewise, there's going to be some copper standards changes, of course. I don't think we realised, or wasn't widely realised, that 61935-1, which is our copper test standard. Edition 5 was ratified back in September last year. It was done very quietly. So now Class 1, Class 2 systems are recognised. That's Category 8. The TCL testing requirement has been recognised. But I think the second one there, the Amendment 2, is of great significance, especially in the world of power over Ethernet. They've recognised DC resistance unbalance measurements in the test standard. So that's now been added there. And as we go forward, you're going to see the standards bodies add single pair Ethernet. This is a new use of copper. And what we're looking at achieving there is 10, 100, and a gigabit Ethernet on a single twisted pair rather than 4 twisted pairs. So watch that space. That's going to be interesting. There are connectors. You'll have a connector for office type environments, and the devices here think IoT, the Internet of Things. Temperature sensors, building access, things like that connected to the network. And it uses an LC footprint style connector. There's two copper connectors. For industrial automation and IIoT, industrial Internet of Things, there's a connector there. It's a more ruggedized connector. It comes from Harting in Germany. And that's the accepted ruggedized style. And where this is going to take us is the manufacturing industry is getting rid of a lot of their field bus technologies and are moving to industrial Ethernet. So you will find manufacturing plants now starting to deploy Ethernet. And here's another opportunity for people to diversify their skill sets and start installing Ethernet cabling for industrial environments. And believe me, some of the people who are working there don't really know what they're doing. And so for some of our members, this could be an ideal opportunity. 11801, and Murray's going to talk more about this next time round. I'm going to steal a little bit of his thunder, but single pair Ethernet has been added. And as you can see there, single pair Ethernet, 10 megabits per second Ethernet out to 1 kilometre on a single pair. So it's quite an interesting thought. And then you've got some higher classes of T1 means one pair of twisted cable, 600 megahertz and 1.2 gigahertz versions for higher speed. So that will roll into section 1, 3, and 6 of the 11. And that will also cover building automation systems and industrial automation, as I mentioned. And there's some study going on to add 25 gigabits per second. 40s no one's interested in, but people are interested in 25 gigabits on copper because it's a multiple of 100, and they want to take that standard out to 50 meters from the current 30 meters. Now the ISO people are going to add MPTL to the ISO standard. They've completed the reference document, which is 14763-4 there. But I want to blow a kudos to the Australian Standards Committee, because we worked on this for the new 11801, the ASNZS 11801 Part 1 that came out last year. It's Annex ZA2 for those of you interested. But what the ISO working group has decided to do is adopt what Australia came up with. So the way we worked it out for the Australia and New Zealand implementation is what the rest of the world is going to be using. As I said, there's a new fibre testing standard. The 61280 standards are the how-to standards that 11801 and 14763 they'll be published this year. There is now a patch board standard for Category 8 patch board that's being dealt with. And the pond people haven't been sitting quietly by the side either. There's a new form of EPON, which takes it out to 50 gigabits per second. So even the pond guys want to get into the act of more speed, more bandwidth. Whether NBN will look at something like that, yeah, who knows? But that's 50 gigabits per second is quite impressive speed down a fibre. And again, this will publish in August this year. One I'd like to mention, we all run into the trouble of what am I supposed to do? How am I supposed to do it? Well, there's an interesting standard from the ISO people, 14763-2. This is the planning and installation guide for structured cabling or customer premises. So it gives you guidance on what application, environment, building infrastructure, facilities, etc. How to plan your installation, pathways, spaces, installation practice, what's best practice, how you should document and administer that cabling system, testing, and it addresses copper and fibre cabling, what to test, how to test, so it tells you what test you need to carry out. And then, of course, you go to 61935 or 14763-3 to get the procedure for carrying out that particular test. So we're completing the documentation. Talks about the inspection of the installation, the operation, and the fact that you should install so it can be maintained. So don't put cables in so that they can never be replaced. And if you have to do repair, look at how to repair and repairability. Yeah. In reality, this is damn near a scope of work. So when you don't have a scope of works document or you're flying by the seat of your pants, here's a document that you can actually refer to. And being an ISO document, we can use that. So to finish up here, and I'm looking on time, which is, as most of you would know, that's unusual for me. Networks are only going to get faster. I don't think anyone would disagree with that. We've got to deliver more bandwidth. And in these trying times when we're all trying to work conference hosting systems, that just speaks volumes. I know in my own situation, I'm trying to work. I have two elder children, one at university, one in year 12. They're trying to do their lessons. And I have a younger child, as most of you know, that's also going to school, and they're all trying to do it over the internet. Standards are evolving to support the speeds. So the standards we work with, whether it's ISO standards, and for those of you who are outside Australia and New Zealand, the TIA and their development of standards is also mirroring what the ISO people are doing. And in some cases, they're in front of the ISO people. So you need to look for these changes. And as an industry, we're going to have to look at new ways of doing things. If you're going to be running power over Ethernet, and a lot of new devices are coming that require power over Ethernet at up to 90 watts, DC resistance balance is going to be a requirement. light source power meters, they're going to be evolving, and make certain that what you're using can support new connector types, because they're coming. Inspection's not going to go away. You need to make certain that fiber's clean. And MPO is going to be a lot more common, so you need to tool up for that to test it correctly. And I mentioned the 14763-2 standard. That's an ISO standard. Well, that's going to be drawn in as an ASNZS standard. We're about to start work on that. And so I would imagine Murray's probably also going to talk about that, being chairman of CT1. That we believe this is a great standard that can benefit the Australian industry. So with that, that's all I have. And I'll hand back. I'll stop sharing. Do we want to open this for questions, guys, on the chat line, or we'll take questions at the end? Daniel, what would you prefer?
Hey, Wayne, hats off. Great presentation. Thank you very much. So great presentation on the advancements with fibre and copper technology, which is truly trying to keep up with more faster and more critical networks that we're faced with today, and particularly some of the examples that Wayne has put forward. We're continuing to hear more and more about one pair Ethernet as well. So just to remind everyone that the 21st of April, we will have hosted on Fluke's, R&M's platform, major changes to ISO 11801 and IEEE 802-3, particularly where it's impacting Australia and New Zealand, which is setting the standard globally. So that will be brought to you by Murray Teal from BTI. So just before we go on, we're just on time, so we'll probably keep going to the next presenter this morning, and then we'll come back to, so just keep all your questions on hand, drop them into the Q&A window now while you are thinking of them, and we'll make sure that we come back to them at the very end where we have our Q&A. So without further ado, I want to give a warm welcome to our second presenter this morning, who is Jason Hanlon, the Commercial Manager Datacom for Prysmian Group. So Jason, are you there? Brilliant.
Or
Jason,
after,
sounds like
whatever you may be.
So Jason's presentation is fibre optics, the need for fibre everywhere is driving densification. So without further ado, Jason, take it over.
Okay, thank you, Daniel. We should be, can you see that?
Yeah, it's up. Yeah, and it fills the full screen, so thank you.
Perfect. The system works. Okay, let's jump into it. Basically, a lot of what Wayne just went through is about fibre and the speeds and applications of fibre, the testing, but he also touched upon the densities with the new connectors and things like that. So I'd like to delve a little bit further into that. We are finding that densities of fibre is being driven by the market, and there are a few things happening with the fibre to allow us to create cables that are much more dense, or fibre dense, should I say. So we have large fibre counts and very small but very dense fibre counts. So there's two different drivers here. So we'll have a quick look at the trends, what's driving it. A1 versus A2, which is, they're both bend-in sensitive fibres. There are more than just the two bend-in sensitive fibres on the market today, but these are the two main ones. Then we'll have a look at the new generation of loose tube cables and the high capacity cables and the high density cables, and the emergence of 180 micron fibres for the future. So what's driving it? Network architecture is changing. The wireless cells densification, so with the rollout of 5G and and potentially 8G into the future. The wireless cells are becoming closer and closer together. IP networks, obviously, they're blowing up all over the place. There's a lot more of those small IP devices popping up around our cities. We need to move the content closer to the edge of the network. So it's the speed to access the content is a lot faster. We've had a very steep growth in hyperscale data center capacity around the world, and the emergence of smart and buildings and smart homes. So there's a lot going on in the telco world, and the only real issue that they're having is the fact that they cannot drive more fibre into the ground in certain areas. So the cost to deploy new networks is quite large. In certain metropolitan cities, fully reinstated, $23,000 a metre to bury a new network. So it's a huge cost. So it's about trying to utilise what is actually in the ground, and so making full use of it, which means putting more fibre into that space, and also making it faster and easier to deploy. The advent of bend-insensitive fibre allows us to do these things, and they are very key to make these dense fibre networks. So putting almost to the point where we're talking about how many fibres per square millimetre in a cable rather than how many fibres are actually in the cable these days. And that allows us to leverage the space that's actually in the ground by putting more fibres in there. It allows us to speed construction because you're pulling more fibres at once. And it gives us an efficiency in the deployment, the speed of deployment. Because it actually, being bend insensitive, it actually is easier to work with, and we can make the cables a lot smaller. We can actually bring down the buffer closer to the fibre in a loose tube cable without affecting the performance of it as much. So here are some of the densities. So very high capacity fibre cables, 6,912 fibre in a 40 mil cable. We're talking about 4.8 fibres per square millimetre. But in the high density but low capacity, we're talking up to 10.5 fibres per square millimetre. So a 552 fibre cable that's 8.4 millimetres in diameter. That gives you a massive saving in space, allowing you to put more fibre cores into your existing ducted network. So if you look at the challenges, as I said before, there are certain areas of cities, metropolitan cities that you just physically cannot access to bury any more conduits. It's not possible to directionally drill underneath parts of it, heritage listings and things like that. So the services are so condensed and so packed, you need to use what's currently available to you. And some of that means ripping out the existing copper and low density fibre networks and replacing them with the higher density cables. So to allow us to do that, we've created bend-insensitive fibres. A1 fibre and A2 fibre are the two most common, but they do actually work very differently to one another. We are conducting tests on the bend insensitivity and the performance of these fibres, both mid-span, so spliced into a dome closure, where we only actually splice the fibres that we need. So we might have a fibre tube with 12 or 24 fibres inside, where we'll actually only take out 1 or 2 fibres, splice those, slack manage the rest, and test the performance of those. And while we're doing that, see how far we can actually shrink down the splicing trays that are inside that dome closure, so the product still performs as it should. And what we're finding in the early results is the G657A2 fibre far outperforms the A1 fibre. And here are some of the results that we're seeing. So if we look at micro bending losses in the bend insensitive fibres, you can see the maximum specification for A1 fibre by ITUT, the standards body, is 0.25 dB per 10 turns for A1, and A2 is 0.03 dB for 10 turns. So you can see a very big difference just between the two types of bend insensitive fibre at various wavelengths. And the higher you go up in the wavelengths, the harder it is to meet. You can see A1 has a full 1 dB loss over 10 turns at 15 millimeters. So it's very different in performance, but both will give you a significant performance over our standard G652D fibre, which is currently about 85 to 90% of the market. When you order single mode fibre, it's highly likely that you're getting the G652.D spec. But that allows you, these bend insensitive fibres just mean that you're allowed to shrink everything down. We can make smaller splice trays, we can bend it around corners and not have it affect the outcome of the application performance. So when we look at A2, that enables us to create much highly packed, dense cables in both very dense, small fibre counts, but also very, very high fibre counts. When we start going over 1,728 fibres in a cable, the reality of it is A2 is almost essential. It's not always, you're not always able to achieve the standards performance required with A1 fibre when you start getting out over that 1,728 fibres in a single cable, especially in ribbon type cables, or in what we call now flexible ribbon cables, so rollable type ribbons. The other thing that we've done, we've moved the buffer around the outside of the fibre from 250 microns down to 200 microns, which saves us enough space to allow us to more densely pack those fibres into the buffer tube. That tiny 50 micron of less plasticizer can actually bring a 12 fibre loose tube element from a standard 2.1 millimeter loose tube cable down to a 1.35, what we call a flex tube cable, which is the next generation of loose tube fibre. So flex tubes, basically, where you have a loose tube cable, you have a couple of elements. You have the GRP rod in the center. You have a hard PBT tube, 12 or 24 fibres with some gel inside that tube. And then you have either water blocking tape or aramid yarn, and then your jacket materials. Back in the 1990s, they invented this flex tube product, which is actually soft, pliable plasticizer that goes around the fibres, and because now with bend-in sensitive fibres, we can bring the size of that tube right down close to the fibre. So as I said, 1.35 millimetres. And that allows us to fit a hell of a lot more fibres into a much smaller space. Where we have the GRP rod in the centre, we've actually moved that and put it into, it's embedded into the jacket material of the cable, and the loose tube, flex tube elements sit inside a hollow tube inside the cable itself, with a whole bunch of water swellable yarns made of aramid yarn product, which is very high strength flexible yarns. And the use of those yarns and the two small GRPs embedded into the jacket gives you a pulling tension for a cable which is equivalent to what you would see in a standard loose tube cable, with a 2.1 mil GRP element in the center and the polyethylene and nylon jacket material around the outside. But what it does, it gives you the ability to bend this product in a much more severe way than what you can with a standard loose tube cable, because the loose tube element is actually very flexible. So yes, you can see up in the top corner there what looks like to be a nice figure 8 knot. You can actually do that, and the fibre still does work when using A2 bend-in sensitive fibre. But it's so much easier to handle, so it lowers the cost of the installation because they lay flat. You can strip it with your fingers. There's a very small amount of gel in there compared to a standard loose tube cable, and the amount of gel in a loose tube cable has come down dramatically over the years, but this has even less. And you can manipulate it far easier, so it's much easier and more pliable for slack management inside your closures or your faux box. So just quickly on the stripping, you can see the loose tube, you need a stripping tool. You need to ensure that the tool doesn't go too deep and cut the fibres. There's a larger amount of grease involved, where with the flex tube, you just pull it off with your fingers. In fact, if you take an alcohol wipe, as you pull the flex tube material off the fibres, you can almost clean the fibres at the same time as you strip them, because there is that much less gel inside that tube. But it's just as strong and provides you with a fast, reliable installation. It's also kink insensitive, so you can't kink it. I've tried many times and still haven't been able to do it, which is another big risk on site, is kinking the loose tube elements. But because it's flexible, you can't kink it, so you're actually saving a lot of time in repairing broken fibres. But it allows us, as I said, to make higher capacity cables. So by taking that style of plasticizer and creating a ribbon using that flexible plasticizer, you can actually roll those ribbons together so they bunch individually before you then put them inside the loose tube element. So a standard loose tube element can now house up to 288 fibres in a rolled ribbon type cable, so a flexible ribbon type cable. And by putting those loose tube elements together, again, we can do that with a GRP rod in the centre rather than embedding it in the jacket. So it gives you the look and feel of a normal loose tube cable. You can create cables, as we saw before, up to 6,912 fibres in a 40 millimetre outer diameter. So very, very high capacity fibre counts. It gives you the ability of stripping the loose tube elements quickly and easily without potential damage from tools or without kinking. And it gives you the flexibility of splicing ribbon fibers or individual fibers themselves, stranded fibers. So you can actually separate those ribbons into individual strands and splice them, as well as splice it as a ribbon. And ribbon fiber splicing will save you a lot of time. You're splicing 12 fibers rather than one. So if we have a look at the conventional ribbon, which is what NBN use in their network, it's basically 12 fibers laid flat, and they use an acrylate to hold them together. It's completely surrounded, and you can't bend it. You will snap the fibers if you bend it. It's hard to strip. You need tools to do it, compared to a flex ribbon technology, which allows you to roll it and more densely pack the fibers into a loose tube element. The advantages is obviously density. So much greater fiber density, much easier to use, and you can fit the 6,912 fiber into a 50 mil conduit, which is let's say 5 years ago, 50 mil conduit would house maybe two 144 core loose tube cables. So you're going from 288 fibers up to 6,912 in the same space, utilizing 200 micron fibers. The only difference in splicing 250 micron fibers and 200 micron fibers is you have to change the grips over in your splice unit to splice 200 micron fiber. So where the splice unit grips onto the 250 buffer, it needs now to have an insert into that grip to allow it to grip onto the 200 micron fiber. The alignment of the fiber at splicing is exactly the same. It's still 125 micron cladded and 9 micron core. But as we continue down the density path to allow our customers the ability to put more fiber into smaller spaces, we're moving towards a 180 micron future. That will allow us to increase the densities of these cables. At the moment, as we saw before, 552 micron fibers being 550 fibers in 180 micron cable, having 10 fibers per square millimeter is quite a very dense cable for a very, very small space. So it's not massive fiber counts, but they will come. It gives us the potential to move that 40 millimeter rolled ribbon fiber out to potentially up to 9,000 fibers into a 40 mil space. The way that a lot of these fiber network guys operate now is the only way they make money is by having fiber. And as you saw in Wayne's presentation earlier, the density of connector is lowering. The need to actually have more fibers to create the faster channels is growing. So we need more fibers in the ground just to sufficiently operate into the future as all of the applications continue to expand and grow and become faster. So at the moment where we're at, using 200 micron fiber, we've basically maxed out at 432 fibers into an 8.7 mil cable. So the challenge that our customers have given us is to make a high density fibre cable that's under 10 millimeters in diameter. And that can be used in blown fibre networks, or it could be hauled very short distances, so lead-ins to data centers, for instance. So 10 mil maximum, using 200 micron fibre in A1, 432 fibres, 8.7. If we go to A2 type fibre at 200 micron, we can go up to 552 at 8.2 fibres per square millimetre. 8.2 millimetres at 10.5 fibres per square millimetre. And when we move to 180 micron, 552 in a 7.5 mil cable, which gives us 12.5 fibres per square millimetre. So you can see the densities changing. We can't get 552 into a 10 mil cable using 200 micron A1 fibres. So you can see that the fact that we're using better bend-in sensitive fibre and we're reducing the outer diameter of that fibre down to 180 micron allows us to compact more fibres into such a small space. So you can imagine in a data center, the footprint for a data center can actually be much, much lower when you only need 5.5 millimeters to run 550 cables around internally in a data center. Real estate's a big cost, obviously. So as we move from 250 to 200, the density's increased. As we move to 180, the density increases again. And that really gets us into this nano cable evolution of blowing fibre into small tubes using the blowing equipment available on the market today, allowing us to potentially fill up more of the duct space that's currently underground that's not being utilised or is considered full, where we can actually insert a very small tube, 10 to 12 millimeters in diameter, into a congested network and have up to 552 extra fibres added into that 10 millimeter space. So starting with the nanofibers at 96 fibres cable. A 96 fibre cable is 5.2 mil in diameter. And as we saw, goes up to 552 micron. It meets the standard. It performs as per the standard. It tests the same. Again, splicing, just using a different grip inside your splice equipment will allow it to splice as per normal. So it's not doing anything different as far as a fibre is concerned than what you see and use today. It's just about maximising the amount of space inside the network. Okay, I'll just jump past that. So that brings me to the end of the presentation. Thanks for your time. I'm sure we've got some Q&A sessions happening. So if you have questions, happy to answer them. Most of you guys know who I am and have my contact details. So please feel free to give me a call if needed. Happy to chat you through some of the developments that are taking place.
Thanks very much, Jason, for your presentation. That was brilliant. So great presentation on the advancements of the fibre technology again and how it's becoming more densified within the cable. So it's getting smaller and smaller. But again, the contractors, the notice on site is insignificant in comparison to what they're doing today, which is quite good. So I'll just jump into Q&A. So everyone, if you've got any questions, feel free to just drop them in the Q&A window, and we'll try and get through them all where we can. So we've got the first one in from Ray Treadwell, and this one is addressed to Paul. Are you online, Paul?
Yep, I'm there.
Okay, so the first one up from Ray is engineering going to recognise our RCDD qualification, or are South Pacific just qualifying the engineers to continue to do RCDD work?
Yeah, this is a long ongoing issue. We've had extensive discussions over the last few years with Engineers Australia, in particular the chair of the ITEE College. I think he's a West Australian. Dr. Walter Green is his name. He is very excited by our RCDD program, and he says that we need to see more of that within the ITEE chapter, recognising the fact that most network engineers are, as that name says, network. They understand the blinking lights, the software, but don't understand the infrastructure. So he's been leading the charge within Engineers Australia to have an RCDD recognised as a chartered technologist. So, and look, this has been going on for quite some time. The simple fact is it's very bureaucratic and it takes a long time to make that happen. But it's still in the process of happening, and we are still pushing away at that. We're looking at a number of other avenues, including what I just mentioned earlier, by trying to get some BICSI ICT infrastructure courses within Engineers Australia or Engineers Education Australia, which then becomes a multi-prong approach.
Great, Paul. Many thanks for that. And then obviously do some of the courses have BICSI CEC credentials attached. I'm pretty sure it's the webinars, is it?
I think that I'm just trying to interpret Ray's comment on that. We have had questions about are any of the Engineers Australia courses, do they have CECs attached to them? And the simple answer is no. The reason for that is the BICSI headquarters requires documentation of all or any course, whether it's a BICSI course, a BICSI event, a corporate event, or another association's event. They need to pre-assign CECs to that. So we're in extensive discussions with BICSI US. As many of you know, it's been a challenging situation to meet the criteria, but we work long and hard with them. And I guess I'll put the call out to any of our corporate members or any of our members who produce education or training material, whether it's just a specific program for a 1 hour event or whether it's a 2 or 3 day course. Let us know. We'll work with you to get these courses, get CECs attached to them. And since the fact that we're doing a lot online, record them, we'll put them on our website and we'll make them available to all of our credential holders.
Brilliant, Paul. Many thanks for that. So it's just the 2 questions that are in. So yeah, thanks again to all our presenters who joined us today. Thanks very much to Fluke Networks for sponsoring the webinar, and also Wayne for presenting, which is much appreciated. And thanks to Jason Hanlon as well for his presentation from Prysmian Group. So without further ado, that comes to the end of the webinar and the end of the Q&A session. Thank you all for your attendance, and we look forward to reaching out to you again on the 21st of April, where we've got Murray Teal's presentation coming up. So please await further information on that. All right, thank you all. Have a good day.